Up to this point, we've been working with PL languages. A PL language starts with a list of atomic whiffs, like P, Q, R, S. And the idea is that each atomic whiff then stands for a whole proposition. So P might stand for Putnam is wise, while Q stands for Quine is wise, R stands for Russell is wise, and S stands for Socrates is wise. Then the logical connectives, conjunction, disjunction, negation, conditional, allow you to make further statements about those propositions. Thus, if you want to say of two propositions that they're both true, then you stick a conjunction sign between them. If you want to say that at least one is true, you stick a disjunction sign between them, and so on. Now we're starting to work with QL languages. Rather than starting off from a list of atomic whiffs, each of which stands for a whole proposition, QL languages start off from sub-propositional components, a list of proper names and a list of predicates, and then those are combined to form whole propositions. For example, we might have a QL language that contains the names P, Q, R, and S, with P referring to Putnam, Q to Quine, R to Russell, and S to Socrates. That language might also contain the one-place predicate F, which could be used to express the property of being wise, and the two-place predicate J, which could be used to express the relation of jealousy. Then the formula FP says that Putnam is wise, FQ says that Quine is wise, JSR says that Socrates is jealous of Russell, JRS says that Russell is jealous of Socrates, and so on. Once you've built up some initial propositions out of names and predicates, you can then use the logical connectives in the usual way. So, for instance, to assert both that Putnam is wise and that Quine is wise, you write FP and FQ. To assert that if Putnam is wise, then Quine is jealous of him, you write if FP, then JQP, and so on. Now, up to this point, using a QL language is not much different from using a PL language. You just start from names and predicates which combine to form whole propositions rather than starting from whole propositions straight away. The really big difference between QL languages and PL languages comes next when we introduce what we call quantifiers into our QL languages. And what quantifiers do is actually really simple. Universal quantifiers say that everything meets a certain condition, while existential quantifiers say that there's at least one thing that meets a certain condition. But they can take a little bit of getting used to. So let me try to explain with some examples. So first, consider the formula FS. That says that Socrates is wise. In other words, and you'll see in just a second why it helps to phrase it in this way, it says that Socrates is such that the condition of being wise applies to him. If we now universally quantify on S, that takes the condition being attributed to Socrates by Fs, which is the condition of being wise, and applies it to everyone. So for all x, Fx says that everyone is such that the condition of being wise applies to them. Or more formally, every person x is such that the condition of being wise applies to x. If instead we existentially quantify on S, then that takes the condition being attributed to Socrates by Fs, and it says that there's at least one person that condition applies to. So there is an x, Fx, so that there's someone such that the condition of being wise applies to them. Or more formally, there's some person x such that the condition of being wise applies to x. Now, consider the formula if Fs, then JPS. That says that if Socrates is wise, then Putnam is jealous of Socrates. Now, the claim that Socrates is wise, which was our previous example, is very easily seen as saying that Socrates meets a certain condition, namely the condition of being wise. By contrast, the claim that if Socrates is wise, then Putnam is jealous of Socrates isn't so naturally heard as attributing a certain condition to Socrates. However, and this is perhaps the key insight for understanding quantifiers, the claim that if Socrates is wise, then Putnam is jealous of Socrates can indeed be seen as attributing a certain condition to Socrates. It can be seen as saying that Socrates is such that if he is wise, then Putnam is jealous of him. That's the condition, being such that if he is wise, then Putnam is jealous of him, that the formula is saying applies to Socrates. The formula, if FQ, then JPQ, if Quine is wise, then Putnam is jealous of Quine, can be seen as attributing that very same condition to Quine. It can be seen as saying that Quine is such that if he is wise, then Putnam is jealous of him. The formula not if FR, then JPR, it's not the case that if Russell is wise, then Putnam is jealous of Russell, takes that same condition and denies that it applies to Russell. It says it's not the case that Russell is such that if he is wise, then Putnam is jealous of him. Now, seeing the formula if FS, then JPS as attributing a certain condition to Socrates, we can make sense of what's being said when we take that formula and quantify on S. If we universally quantify on S, yielding the formula for all x, if fx, then jpx, that takes the condition being attributed to Socrates by if fs, then jps, and attributes it to everyone. So it says that every single person, so not just Socrates, but also Quine, Russell, and so on and so forth for every single individual, is such that if they are wise, then Putnam is jealous of them. Or more formally, every person X is such that if X is wise, then Putnam is jealous of X. If we instead existentially quantify on S, then that takes the condition being attributed to Socrates by if Fs, then JPS, and says that it applies to at least one person. So it says that someone is such that if they are wise, then Putnam is jealous of them. Maybe Socrates, maybe Quine, maybe Russell, maybe someone else. The formula doesn't say, it just says that someone satisfies that condition. Or more formally, it says that there's some person X such that if X is wise, then Putnam is jealous of X. Now, it's not just the formulas Fs and if Fs, then JPS are two examples so far, which can be seen as attributing a certain condition to Socrates. Any formula using the name S can be seen as saying that a certain condition applies to Socrates. Taking that formula, whatever it is, and universally quantifying on S, will say that the condition previously being applied just to Socrates, in fact, applies to everyone, while existentially quantifying on S will say that that condition applies to at least one person. In general, that's how quantifiers work. When you universally quantify on a name, you're saying that everything meets the condition that was previously being applied to just the name thing. Whereas when you existentially quantify on a name, you're saying that at least one thing meets the condition that was previously being applied to just the name thing. For one last example, let's take the formula JPS. That says that Putnam is jealous of Socrates, which can be seen as the claim that Socrates meets the following condition. He is such that Putnam is jealous of him. So if we existentially quantify on S, we get a formula that says that at least one person meets that condition. In other words, the resulting formula says that at least one person is such that Putnam is jealous of them. That is, there's someone that Putnam is jealous of. Now, note that the formula there is an X, JPX, can in turn be seen as saying that Putnam meets a certain condition. It says that Putnam is such that there is someone that he is jealous of. So if we universally quantify on P, the resulting formula says that everyone satisfies that condition. That is, it says that everyone is such that there is someone that they are jealous of. In other words, everyone is jealous of someone or other. Now, let's go back to the formula JPS one last time. Rather than seeing that formula as asserting that Socrates meets a certain condition, we also could have read it as asserting that Putnam meets a certain condition. We could have seen it as saying that Putnam is such that he is jealous of Socrates. Then existentially quantifying on P would be to say that at least one person satisfies that condition. That is, the resulting formula would say that at least one person is such that they are jealous of Socrates. That formula, in turn, can be seen as asserting that Socrates meets a certain condition, namely, he is such that someone is jealous of him. So if we were to then universally quantify on S, the resulting formula would say that everyone satisfies that condition. That is, everyone is such that there is someone that is jealous of them. In other words, everyone has someone who is jealous of them.